For joining us, everybody. I'm so happy to see you all here. This is the September Rust Meetup. As you know, this is a web-related meetup, a continuation of the one we had 2 months ago. Today we have two illustrious Rust community members talking about web technology. Alan Andrade, talking about his Oxidized JS framework, which is a library for doing compression. And then the incomparable Chris Morgan, who I'm sure everybody is aware of, talking about Teepee and the future of Rust and the web. And miscellaneous web things. I'm so excited, and I hope you are too. So without further ado, let's get started. Alan, come on up.
Thank you. All right. Oh, this is not it. Hold on. There you go. Oh. Cool. 1 second. Can you hear me all right? Yeah, okay. I hear some echoes. Okay. So I'm connecting to the internet. Let's do like guest. Okay. All right, we're ready to roll. Cool. Thank you everyone for being here. My name is Alan Andrade, and I'm going to talk about Oxidized JS, which is a tool to do parallel JavaScript compression. Before I start this talk, I would really like to give some background, because I know there's a lot of difference in expertise here. So I just, want to share. I remember when I was in high school, I started learning about C. I mean, that was pretty late. And I remember that I stopped when I got to pointers. I was like, what the hell is this, right? And I just I dropped that book. And then in college, I met Ruby. Every project I would do in Ruby. After that, I started doing Ruby on Rails. And that's what I'm doing right now. Later on, I jumped into JavaScript. I really enjoyed the Ember framework. And after all these things, Rust happened. And has been amazing. Thank you for that. Cool. Let's talk about the problem. So when you have a Rails app, it tends to grow like a lot, right? So when you deploy your app, it takes a lot of time. Let's assume this Rails app that I'm talking about is using the Rails asset pipeline. When you deploy, it normally takes like 10 to 15 minutes plus extra time, and that extra time is, uploading your asset somewhere, whatever. Also, the reason why we want to pursue a faster time in these deployments is because we want a faster release cycle, right? Okay, so let's talk about potential solution to this. I want to cut down the 15, 20 minutes deploy down to 5 if it's possible, 10 if it's possible. All right, let's unwrap that. let's parallelize with Rust. That's the first thing that I thought. I was learning Rust. I mean, I'm still learning. I mean, and I thought, I mean, it would be amazing if I can solve a problem and also teach myself some Rust. And I didn't know how to start. How do you parallelize, ACID compressions? It's starting from the fundamentals. How does a tool that we currently use compress and minifies JavaScript? So the first thing that was natural to me was to use Rust and Uglify.js, which is the minifier compressor that probably the best one out there. Let's talk a little bit about Uglify.js. Uglify.js, it's a compressor minifier, as you can see right there. And it consists of different parts. Uglify.js has a parser, so that means it will yield some AST. Also, it has a code generator, which will write some JavaScript from the AST. We have the compressor, which is it uses a transformer API, which is something that we will see on the next bullet point, and it optimizes it. It optimizes the AST into a smaller one. A mangler, which is it gets rid of variables that you use. It compresses your variable names to the minimum possible. We have the scope analyzer, which augments the AST. I really don't know what that means. It says it augments the AST with information about where variables are defined and referenced. Probably people that work with parsers know pretty much what's that, right? I don't know. Tree walker, it's very simple. It's an API so that you can walk the AST. And then we have the tree transformer, which is the API that the compressor uses. So that's an overview of Uglify.js. Next up, I want to talk about the architecture. So we have a manifesto, or whatever you call it, and it is in a JSON file. And this manifest, the Rust code, what it will do, it will separate your files into chunks, evenly distributed among your CPU cores, so that you distribute the workload of compressing into your cores, CPU cores. After we have these chunks of paths, as you can see there, we use Uglify.js. And we use those paths to feed the Uglify.js process. At that point, we run Uglify.js only with a compress option. We do not mangle right there. After we Uglify, we use channels to synchronize the writing of the output of Uglify.js. Otherwise, we would get like gibberish and overlapped outputs in a file that right now, I don't know if it's good to put it in a file. Probably would be better to keep it in memory, and that's one of the things that I'm still stuck with. I don't know what would be the best option. So after we Uglify it, we use the channels, we unify it in these temporary JavaScript, and after we unify it, we run Uglify again with the mangle option. Finally, this Uglify.js will yield the result of oxidized.js, which is a final product. There are a couple problems that I see with this implementation, and these like the first idea that I got about Uglify and how to make it, about oxidized.js and how to make it parallel. So one of the things is I feel we lose a lot of time in parsing, right? Uglify parses and then generates JavaScript and then spits it out. Then we parse it again and we do the same thing. That's really wasteful, it sounds to me. Okay, let's talk a little bit about the results. Let's try that. I don't think this is still a reliable architecture so that we can, make, yeah, this is awesome, or a good project, or we have good improvements. However, when I got a version working of this architecture, I did a simple example of that's a pretty quick roadmap or a pretty quick explanation about what Oxidized.js does. And let's think about what's next for this project. I would really like to know if we are on the right path. Is ECMAScript coming out with new standards that do not require compressing? Are there other ways of doing these same tasks? I still don't know, and the knowledge I have about that regards is reduced, at least at this point. Also, I was in a previous meetup here. I was talking to somebody, a Reduce, which is not here today. Well, that's his IRC name. I don't remember his real name. But he was talking about, well, okay, so you will parse it and then play with AST, and I was like, yeah, that's what Uglify.js does, but I don't know, like, should I write the parser for JavaScript in Rust? That sounds like somebody else have done it before, right? I don't know. And I mean, I thought about like a C or C++ implementation so that we can, it's pretty easy to talk with a C or C++ interface, right? So I don't know why I cannot find that. I was thinking about, okay, so SpiderMonkey, is that number, the name, sorry? I was, okay, SpiderMonkey should have it. And I don't know, I cannot find that thing, that parser, that at least can give me some AST. I talked about that already. And then if it happens that we find the C or C++ implementation, can we feed Uglify with these AST in a JavaScript representation so that we don't have to rewrite what Uglify.js does already? And the last question would be, should we compress, minify, parse, and do everything ourselves? I don't know. So if there's anybody out there writing a JavaScript parser, I would really, really like to help with that. And let's see how that goes. That's pretty much it about Oxidized.js. It's a pretty small project, and it has been amazing to work with Rust on it. Before I wrap up this small presentation, I would really like to say thanks to Steve Klabnik, who wrote the Rust for Ruby's guide. That's the guy that brought me into this community. And after that guide, I was hooked, and I cannot. I'm at work thinking about Rust, so I don't know if that's good. I love this community. And I'm super happy to see people joining, new people every time joining to these meetups. Keep doing that, and I'm pretty sure you will love this community. Also, IRC, people there are super helpful. thank you everybody in the IRC channel. I'm probably, if you remember me, it's because I was bugging you with really stupid questions. And also, about the Bay Area Rust Hack Nights, I organized that meetup, and we have only had one meetup ever that happened at GitHub, and was pretty good. I discovered that day that hack nights are not great because people, are tired. So I was thinking about moving it to a different day, probably Saturday. And also, I'm interested in switching the hack day. It's not a hack night anymore. The hack day in San Francisco, then one in the East Bay. Like switching every week or every 2 weeks. So if anybody is, willing to help on that, I'm looking for somebody that is in San Francisco. I have the East Bay already covered. Thank you very much for listening and for your attention. Do you have any comments or questions?
I'm really curious about your goals here. Whether, if you're just trying to reduce the amount of information you have to send down the pipe to the browser, you could do that by simple, zipping or something of the data. And if you want to minify this stuff, you could do that as a separate step to compression. So I guess what I'm wondering about is, did you try as a baseline test, for instance, saying, okay, how long does it take to simply zip the files, and how does that compare? And you could also probably do some kind of parallel zip to get the parallelism as well.
Yeah, this problem, or I guess this solution is, is strictly targeted to Rails users, and that's because, like, when you deploy a Rails app, it will try to compress, minify, and give you one JavaScript that is already like minified to its fullest, and then if you want, you can use-zip that. The thing that I'm trying to get faster is the process of minifying that JavaScript. So my understanding to your question is, I don't think I am solving the same problem you are asking about. I think that's solvable. There's a different solution for the post-deploy, and I am in the phase of pre-deploy deploying stage. Does that make sense? Cool. Well, I guess that's it. Thank you very much.
Alan, that was so amazing. The last Rust Hack Night was super awesome, and I can't wait till the next one. All right, next is Chris Morgan talking about all kinds of stuff related to the web and Rust. Come on up, Chris.
There. Auspiciously entitled Miscellaneous Web Things. This talk, for any of you that have gone watching the video of my talk at Strange Loop, is substantially the same as far as the slides are concerned, but I will be taking a much more strongly Rust focus, and there are a few extra goodies here as well. Okay, first of all, I suppose I should have just a little bit of background about me. I am a web developer by trade. I've been interested in the web since probably about the age of 11. That took me ages to understand CSS. But I've been working with Python as my preferred language for about 6 years. and I've been using Rust for the last year and a quarter or so, and Rust has been absolutely spoiling Python for me. Okay, we had this model that everyone follows. You have a certain amount of time in which you wish to get a product to some people, and you will make money from that. That's the commercial model that we have. This time that we have is very limited, because otherwise you'll run out of money. And also with venture capitalists at present, they don't seem to mind whether you make money or not. So this whole time thing, it's a bomb. I will be talking substantially and specifically about web servers here. Client-side stuff, I do have a vision for where Rust can fit in the client side as well, but for the moment, let's be satisfied with server-side, because, well, the front-end guys, they're stuck with JavaScript anyway, for the moment at least. Okay, so who among here is not a practicing web developer? Let's say about a third of you. People using fully dynamic languages, for professional web development. Yep. That's probably around about half, a bit more. People using VM-based languages professionally, 8. So that's, we'll call it about a quarter. People using compiled languages. Note, I'm saying nothing about the type systems here. Go and see their type systems are rather weak. So compiled languages, I see 4 hands. So that's the fewest of the lot. And yet this is where Rust fits in. Incidentally, as to the colouring of the logo, ongoing debate as to whether that should just be plain black. If you note the stickers that Brian has back there, they're all black. The coloured version of the logo may be on the way out. Anyway, so we have this situation where most people are using the dynamic languages. So they use these dynamic languages. Why? Because they think that they can use them to produce the result on this ticking time bomb the fastest. And so they use that to get the results to the people and make money. The problem is that this causes various bugs and so on, and it's also slow, so you end up with needing lots and lots of machines. And this all ends up causing problems, and they don't end up making money out of it. Simplification, of course. We then look at what people do after this step. You look at, say, Twitter, for example. They say, we've got this problem. We want to get rid of some of the bugs that we have. We want to not need so many machines, and we want to make money. How do we do this? Well, the solution that they used was get rid of Ruby, which they had been using, and use Scala instead. Of course, it's an open question, why aren't they making money still? But never mind. Okay, so we have this whole performance aspect of it, because, yeah, performance is likely to be important to someone that's using Rust for web development. Initially, these dynamic languages, they're very appealing, because they don't have this compile time. However, they do have development server startup time, which is frequently 5, 10 seconds, 30 seconds even, once you're getting to a big project. And once it's all started, the performance is slow. However, with Rust, once you've got the compilation over, which, yeah, it takes some time, you know, it's really, really nice having a server that you press the enter key and nothing's happened. Oh yeah, I forgot to put in a print message. It's already started the server before I had even finished lifting my finger from the enter key. You really can have the entire HTTP stack starting in just a few milliseconds. And once it's all started, it is fast. So we get then these sorts of graphs, this being a New Relic thing. That large pale blue chunk there, which is taking in excess of 300 milliseconds there, that's all the Ruby code. Of course, this was an example where people have been doing bad things that are computationally intensive, and so in that talk, New Relic were demonstrating how to get that considerably smaller. But still, they're only looking at cutting it down to 50 or 100 milliseconds. In Rust, I would be confident that that stuff, you'd be looking at more 1 or 2 milliseconds. It really is that much faster. You can reduce the costs a lot. And as everyone knows, especially in the e-commerce world, response time is actually connected with revenue. People then complain, but this compilation phase, it's a real problem, so we shouldn't use Rust because it has this compilation phase. Of course, that's merely an excuse. Everyone has their test suites, which run really, really slowly in the Rails world. I understand it's perfectly normal to have test suites that may take 8, 20 minutes to run, whereas in Rust, you're less likely to have tests that take that long to run. Or maybe our package manager, they're very good at taking a long time as well. NPM, bundler, any of these things, they tend to do a lot more work than they need to for a lot of things. Of course, we're not going to escape from that with cargo either, so, but never mind. The problem is people use these excuses, but really they are just excuses. We'll come up with ways of making things slow however we do it. We're very good at doing things inefficiently. But then this compilation phase, what is Rust doing in that time when it's compiling stuff that people are complaining about? I would argue that it is saving you time, because there are various classes of errors that it's picking up on, which you have made. It may not be saving you time up front. It certainly does give the impression of making things take longer, but in the long term I believe that it is actually faster. Let's take a completely synthetic, made-up example which just happens to show that Rust is better. So, well, yes, I won't bother reading it all out there, you can look at it, but the end result, even accounting for this 2 hours of hallway sword fight without a legitimate reason, is that Rust is a full minute faster. Isn't that marvellous? But then, who are the people that are saved time? Because I'm claiming that Rust has good performance and is fast for more people, more than just runtime performance. Users, the response time in whatever they're using is decreased, and there is that inverse correlation between response time and revenue and happiness as well. People are likely to be happier if it's faster. There are also very interesting questions of ethics there. I can talk more about that later on if you're interested in it. Developers, maintenance, once you have the type system of Rust, you can use it to avoid various problems where before you would have had a complete start up your development server, run your tests or whatever, find something's gone wrong. And you also, in dynamic languages, often end up writing tests, which takes quite a long time for things that the compiler would have caught in the first place. So in Rust, you simply wouldn't have needed to write the tests. So fewer users get annoyed if you have fewer bugs in your system, and so you spend less time dealing with your customers. And software developers don't like dealing with customers, do they? Also, in operations and your servers, you'll end up with lower resource usage. To take the example of Twitter, when they were merely switching from Ruby to Scala, and Rust would have been even further along that way, they were expecting performance improvements of about a factor of 10 by the change. They actually found that they got performance improvements of about 50 there. So it was considerably better than they'd expected. So that means that for every 50 machines that they had before, they can reduce to just having one. Of course, those sorts of calculations only really matter if you're dealing at significant scale, but never mind. They're still worthwhile considering. And so that naturally saves you money as well. We're used to the saying that developer time is more important than machine time, but especially once you're working at a big company, that can actually pretty quickly become not true. And also, a lot due to this, the type system there, the security is improved because there are various classes of problems that simply can't be represented in the type system. And so you end up having to spend less time dealing with security vulnerabilities, telling people about it, loss of reputation, all of these sorts of problems. So now, let's consider why you need this good type system. I'll take as the case study HTTP headers, and I'll be looking specifically at how Teepee does it, actually. HTTP headers, they're stringly typed in almost every library out there. There are a few that aren't, but the very significant majority of ones, and practically all the ones that are actually used significantly, are stringly typed. This is wrong. Headers are not strings. Semantically, they are not strings. So this makes me sad. This was, in fact, the reason why I started writing Rust's HTTP libraries when I first started writing Rust code, because I was afraid that if I left someone else to write the libraries, they would go string typing the headers. Take, for example, then the do not track header. So it's a very simple header. It has a value 0 or 1. In a language like Python, the code block at the top there, it's a very simple thing. You have a dictionary, as it would be in Python. Keys are strings, values are strings. The value might not be there. And so that's how you track your 3 states there. But with the way things are arranged in Teepee, we can have it all tied into the type system. So that the very fact that we are passing in this value d and t, that is enough to specify what the return type of that method will be. And so we have a semantically correct header type there. And so it is either some opt-in, some opt-out, or none. This then is the implementation of that particular header type. It's, as you can see, a pretty simple sort of thing, a very basic enum. You go specifying how the header is parsed and how it's parsed from a stream. Actually, it's not a stream, it's a slice of vectors there. That's because it's already come out of the stream, because these are all done lazily for various reasons, which I can talk about later. And also how the header is then put back into your stream. Some people at Strange Loop were wondering why these are so verbose. They wouldn't actually need to be quite so verbose if we didn't care about performance. But as it is, caring about performance, say you want to use a writer on the formatting method rather than taking it to an intermediate string. So it ends up slightly more verbose that way. And that macro there, that comes down to something like that. As a matter of fact, so you have that associated types stuff there. It's actually not using associated types yet. At present it is using generics. The reason it can't use associated types yet is because of this business here. So we have the constraint. We would need to apply a constraint there, which can't be represented yet, but that will come. So this then is the overall stuff there. We have the trait, the basic marker trait, so the DNT type here, which is used as the parameter to the get method. And that, so when we pass in there as the header marker DNT, it then says, well, the return type will be its header type, which was that enum. And so you can very neatly encode into the type system this notion of strongly typed headers. The really good thing is that it simply can't go wrong there, because it's all in safe code. Actually, I think that there might be a little bit of unsafe code there for performance reasons, but it can be represented entirely in safe code. Now, I won't lie at all. This is something that you could do in dynamic languages, but it would be hazardous, and the full extent of it would not be neat to do in a dynamic language. The reason I say it would be hazardous is because you don't have the type system to catch you when you make a mistake with it all. And so this type system, it allows you to do things like this that people are just normally too scared to do. It lets you do these things, but be confident that it is actually correct. And also with the way that it's implemented in Teepee there are no privileged header types. You can have multiple headers using the same name, and it will decode the raw value as the appropriate type whenever you ask for it. So, say if you had two different libraries with their own do not track header types, that's no problem. It can cope with that. And that is actually a part that would be harder to do in a dynamic language. I'd just like to re-emphasize, headers are not strings. All clear on that? Good. Let's then take just a quick look at an example of some of the sorts of things that will be possible in Rust. I haven't gone implementing the significant majority of this stuff, and note that /web, it's dealing with the full web stack, so client-side as well as server-side. /web is a language in the Haskell and ML traditions, so it is thus somewhat unreadable to the layman who is used to these languages like Ruby, Python, JavaScript, and that's why it's going to fail. Well, that's why it has already failed. And that's why I believe that Rust has a much better chance. Rust is pragmatic, Rust is familiar. And so although its type system is not necessarily as good as some of these things, say Haskell, it has a better type system than Rust. But Rust is approachable. Rust is something that the layman can use. But let's go back to looking at some of these things. So code injection attacks, they include in that in HTML injection, SQL injection, any of those sorts of things that you can imagine. By using a strong type system, it can simply avoid these problems. Invalid HTML, they are all the sorts of things that we can represent in Rust. Take, for example, I want to see someone experimenting with compiling templates semantically and using the power of the type system. Something like this. So inside here we have A. This A, the value there, it's just a plain string. It will need to be HTML escaped. B, it will need to be HTML escaped. But then again, what if it is already HTML? It might be HTML, so you're going to need to accept something which is declared to be safe HTML or not. C, this is the place where all your escaping systems in Django, Rails, this is the place where they fall apart, because almost invariably the only type of escaping that they know about is HTML escaping. So in C, in location C there, what we're expecting there is actually a URL. It would be wrong, semantically incorrect for it to be anything other than a URL. And the escaping rules are different. If you go applying HTML escaping rules there, it will break. In D as well, if you go applying HTML escaping rules, it will break. And what's more, something that will be passed by it as perfectly clean HTML will be bad JavaScript. That's where you get those injection things. We have all the ability to have this semantic information, which we're just ignoring. And that's not a good thing. The auto-escape that existing frameworks have is simply not enough for meaningful security. So these sorts of ideas, these are things that I would like to see people experimenting with. See what you can do. You can get similar sorts of things with SQL. These security bugs that we have here, they simply don't need to exist. In a language like Python or Ruby or JavaScript, they are comparatively unavoidable. In a language like Rust, most of these security bugs, they simply don't need to exist. We need to get rid of them with our type system. There's an article that I have linked there, Structurally Fixing Injection Bugs. It goes into these topics in some more detail. So we have a type system. Let's use it for correctness, because correctness is a very important thing as well. But we've also got to remember Rust, its goal is pragmatism. It is, if we want these ideas to permeate through web development in general, we need to embrace the pragmatism. We need to realize that we've got to go for something that people can use, even if it might not be quite as good as we could achieve if we wanted to go carefully into all the theory things. Rust is not Haskell. We do not have full monads, and I am happy for us not to have monads for the moment. Eventually we can have monads, but for the moment, monads would be very bad marketing for us. I simply don't have time here to go into all the good stuff in Rust. Rust's ownership model, it's something that I've been sorely missing when I work in Python, because you end up just not being able to reason objectively about something that I've grown used to being able to reason objectively about. Using the type system for errors rather than exceptions and so on. It's a very nice thing to have. We've also seen how Rust can integrate with dynamic languages. Say, the quick version of that is you look at what Yehuda Katz and Tilde have done with Skylight, where the majority of their product there for tracking Rails applications is written in Rust, because they decided Rust was simply the best language that they could find for it. And there are many other great things about Rust as well. So the summary of all this is, if you want to get rid of all your bugs, okay, most of your bugs, lots of your bugs, some of your bugs, a few of your bugs, maybe one or two. If you want to get rid of some of those things, if you want to reduce the number of machines you need to make things faster, make money, make your users happy, throw away your dynamic languages. Use Rust for web development. A good quote here from the Bible. Of course, it is not reasonable to expect you to just throw away all your Python, Ruby code bases. You will need to keep them going. You may find that in your experimentation with Rust, things don't turn out so well. You find that some of the increased verbosity, some of the increased memory capacity that you've got to deal with, I mean your own memory capacity, not computers, because you'll find memory usage goes down a lot too. But just some of these things, Rust is conceptually more complex than these other languages. Make no mistake of that. So yeah, keep going with these other things. Try Rust out as well, because you may find that one of them suits your purposes better than the other. Now briefly, just about Teepee. A month ago I was here for the last meetup, and then on the following Monday I went cycling off into the distance on my recumbent tricycle towards St. Louis for Strange Loop. I actually only made it as far as Lucerne Valley before I had a mishap which resulted in a wheel being bent. And I straightened it enough that I could continue, but decided didn't quite trust it enough to continue going through the desert where there was no one around. So I went back to the nearest town, hired a car, went via the Grand Canyon for a couple of days. But during all that time, I found myself simply disinclined to do anything to do with computers, which I haven't felt for many, many years. It was very interesting. So yes, TP and so on, it all just stalled while I had this holiday. It needs to get past this stage soon, but there are some pretty tricky questions to do with how precisely parsing in particular should be handled. I would be interested to go talking with various people about it afterwards, perhaps at the table over there or something like that. If you're interested in helping out with that, feel free to come over. And I think that that's it, yes. Anyone have any questions, complaints? Yeah. Oh, sorry, yeah, I should have specified what TP was. So first of all, we had Rust HTTP, the HTTP library, but it was largely experimental. I was figuring Rust out as I went there, and it got to the stage where it needed to be replaced. So TP is the redesigning, or the designing of an HTTP library from the ground up. thus naturally prone to second system syndrome and all that. Anyone else? Anyone on IRC gone talking to me? No one talks to me. Ah, well. Yeah. Yep. Go ahead.
Yeah, I've got a question about the Rust compiler. I agree with you that it's nice to have a system which will do type checking for you and make guarantees for you. On the other hand, it's also nice to have a system which is responsive for development, like a REPL or like a fast interpreter. So I guess my question is, I don't know anything about the internals of Rust compiler. Would it be possible to build something which ran quickly but did not make all those tests, and then you could use that for development, and every so often, like the testing people do, say, okay, now run the full set of checks to see if I'm doing anything stupid?
To the extent that you say no, to a more limited extent, I hope so. I'm just waiting for someone else to do it. Yeah, there are various things that can be done to improve performance in those sorts of things. Say background compilation, that's something that can be done. Also, if you do turn off all optimizations, there are various other tricks that you can do to speed things up somewhat, but still, certainly, compile time performance, I would say, is just about the weakest point of the whole lot. But that's acknowledged to be a problem with Rust as a whole. So there will certainly be ongoing work towards mitigating those problems. Sorry, yeah.
Yeah, so for, I guess, the traditional difference between dynamic languages like Python or JavaScript and static compiled languages was when you're prototyping in a language and you're sometimes you're messing with the data model and you're changing it a lot. A lot of times in traditional languages like C or C++, it's a little cumbersome to make changes like that. Because they're verbose and it requires a lot of changes in different areas. How does Rust kind of mitigate this?
I don't know. We'll find out with some of these sorts of things. I am hopeful that they will work well. A lot of it will come down to the design of any framework, making it designed to cope with these sorts of things as well as can be done. But these are points where it may not turn out as well as I expect it to. That's why I give this advice. Keep going with your dynamic development, but try out Rust. See what a good type system can do. Did someone speak to me? Ooh. Yes, that's a good point too, that there is parallel compilation now, so if you go splitting things into smaller crates, they can be built. They can be built in parallel, so some of these problems are reduced by parallelization.
How does it compare to C code for, let's say, a fairly, I guess there's not many large code bodies in Rust, but one of the things of C++ that I noticed is that as C++ projects grow, the compilation and link time grow dramatically. And this really impacts that whole debugging, make a change, compile, run a test, feedback cycle for developers. And this is actually one of the things that make me like C again, is being able to quickly affect a change in the code and see it running quickly. And Scala is another language that has that problem very bad, where there's very deep analysis.
Scala is reckoned to have really, really bad compile time problems. I think that, I get the impression that it's robust it will be.
So if just turning off the optimizations makes everything a lot faster, that's actually fine for
Development,
debugging.
yes. Certainly.
But if it's just inherently painfully slow, that's a problem for a large
The significant majority.
I think that's the reason that things like Linux are huge C code bases that are still successful is it's not that painful to build. If that were in C++, it would probably take several times longer to build.
It's worth bearing in mind with so with C, the standard model that you'll have. Actually, I should change this to black. Sorry, black. I meant black, not blue. B is blue rather than black. K is black. The C model is to have you have lots of different files, and you then go building each of these files individually. So 1, 2, 3, 4, 5, 6. If you change just one, you might be able to do that, and then you go link them all. With Rust, or no, with C++ as a whole. But with a lot of these things, you end up with the big monolithic model, where you just have one thing that needs building. Splitting things into crates can mitigate that a lot, so that you are working with smaller boundaries, so that you are just back to working with, okay, those scales don't work. Oh well. But there is not so much inherently good about C as you might think. There are various things in Rust that can and will be improved over time, where there simply hasn't been time to experiment with improving them yet. Because at present there is one Rust compiler of any seriousness at all, but, well, how many C compilers are there about there? There has been an enormous amount of work into optimizing that. These are things which I certainly hope will be improved significantly in Rust as it gets more popular. And yeah, I'm backing Rust because I believe it is most likely to succeed. Can someone say something in here? Yes, my concerns for parsing. There is this scary thing in HTTP which has a number 2 in it. HTTP 2 is rather difficult to manage, because with HTTP 2 you go implementing full multiplexing and dependency management and stream priorities all over the one stream. Managing that in a sane way, and having it map onto some task model or whatever, but still keeping it flexible, is hard. Deciding also how precisely to balance performance with correctness, that's a fairly tricky thing as well. Say, Joyent's HTTP parser, which is used by Node, Nginx, and so on, it's a monstrosity which needs to die. It is a really, really horrible piece of code. It's a marvel that it works at all. It's had, in my first read-through of the code, I found at least 2 rather severe bugs. It's not a nice thing.
For what it's worth, their HTTP parsing library used to not fully parse the request method. So if you call like POSQ, it would parse it as a post. I think it's been fixed since, but
that was one of the ones that I picked up on my first read-through, where it simply wasn't checking things properly. But yeah, deciding whether to go for an iteration-based model or callbacks or whatever, or phantom types, there are various approaches that can be used with pros and cons. I have a couple of prototypes that I can show people afterwards. But John Ream won't be here for that. Sorry, John. At least, John, you can know that some of these things are things that I discussed vaguely with you a month ago. Yep.
Yeah. One of the motivations for Go was dealing with the long link times that Google was having at million-line systems. And so I guess I've got 2 questions, and one is, do those kinds of how do those problems play out in the Rust implementation, and can Rust steal any of the ideas that Go uses to mitigate those?
Anyone from the Rust team who actually knows about this stuff want to say something about it? because I don't know much about these areas of it. Take a microphone, or come here or something. Yeah.
I don't know much about the link strategy that Go uses, but one of Rust's core values is to integrate with the system tools. So in that respect, Rust wants to use the system linker. So unlike Go, we don't want to write our own linker. We just want to use Go or LD that comes with the system. So we're kind of beholden to whatever the linker performance is by default.
So in Rust, as I understand, the first most expensive thing is optimization, and the second most expensive thing is, I think it's actually type checking right now. Yeah. But mostly it's just the optimization, also sort of stuff like dealing with failure or generating landing pads for that. But it's not the sort of stuff you add in C++ where it's all these weird header files, you have a lot of disk I/O and parsing. It's more just actual sort of thing you might think the compiler should be doing to make sense. And so I know how that works at scale. And it's not properly going to count differently than C++, that's for the better, of course.
Any other questions?
I just want to thank you for a really entertaining talk. I was curious if you're...
Not sure if that microphone's on.
Yeah, it's not.
Don't know.
Anyway, are you using Rust for web development projects that you're doing yourself?
No. You see, I came to Rust wanting to write a web framework because I determined that the language was the only one that was even decently suited for the goal, the dream framework that I had pictured. The problem was that, well, there was no HTTP library there, so I've been busying myself shaving that yak first.
Yours is the only one right now?
No, there are a couple of other ones. Conduit has been doing something in the area. Hyper as well. I'm not sure on the details of Hyper at all. I gather that it popped up while I was away mostly, and Conduit I haven't looked much at all. But they're probably popping up at least to some extent because I haven't been getting on and finishing Teepee to a usable state, because at present you can't use it at all because it doesn't have any of the stuff to actually handle streams.
So I've heard Teepee described as Rust's first vaporware.
Yeah.
So is it going to ship?
It's one of these things where whatever I answer, well, look, if it's going to be vaporware, I'm going to say yes anyway, aren't I?
It ships when it's done.
Yeah, I am intending to be getting back to working on it, but intent, what is intent? But yeah, we can talk about it further afterwards. I certainly want to get it to something that's usable. And by the way, if anyone happens to want to hire me for working on Rust stuff rather than Python stuff, I'd love it. Or sponsor TP development. Yeah. Anyway, any other questions? No one seems to be saying anything. No.
Thank you, Chris. That was super entertaining. Do you mind if I say a few things about some of the issues that just came up there? Bryce, on your question about using HTTP in production, I wanted to note that Cargo has a centralized repository that is web-based. And it's not online yet, but it's going to come online the next month or so. And this is going to be, it's almost entirely Rust. and it's going to be exposed to the web. It's going to be Rust doing the web in production for the first time that I'm aware of, and it's going to be scary. But it should be rock solid.
There has actually been a basics like the Rust Korean user group, I think. It's been running on a Rust backend for many months.
Really? I wasn't even aware of that.
It's crazy to do it.
That is crazy. On the topic of compile speed, I thought maybe I could inform you about some of the developments that are happening there and that might be expected in the future. Everybody knows this is kind of Rust's Achilles heel, that we're slow to compile. In general, Rust compilation is divided by two phases: the analysis, which is all Rust, and optimization and code generation, which is all LLVM. In general, compilation is dominated by LLVM. Recently, a parallel code generation patch landed, which takes the LLVM step and divides it into some number of threads. This is not on by default, but it can provide speedups. The same author that did that, Stuart Pernsteiner, has an incremental compilation patch, which is supposed to specifically address the development cycle. So it only recompiles things that have changed, and it does kind of interprocedural analysis to just figure out exactly the code that's changed and only recode gen that. And that should provide a lot better experience that the dynamic language developers are familiar with. Beyond that, it gets a lot harder, though, to get improvements. What you'll see probably past that is the next lowest hanging fruit is simply improving Rust's IR generation, the code that we're feeding to the LLVM backend. Right now, we're kind of notorious for the poor quality of IR that we send to LLVM. We really lean heavily on LLVM to do optimizations and kind of perform optimization miracles to make the code fast. If you look at Clang's output versus Rust's output, Clang's IR looks really nice. It's treating LLVM with a lot of respect. Rust just dumps garbage on LLVM and expects us to perform miracles. So there's some low-hanging fruit there, and that's probably the next place we'll go. Beyond that, it's probably going to take an entirely new backend specifically designed for performance to make Rust really fast at compilation time. And there are a few people that have ideas about that, but that's kind of a multi-year project. But I do want to emphasize that the compilation performance is not as dire as it may seem right now. There's a lot to do there, and there's a lot that can be done. Finally, that was awesome, Chris, and awesome, Andre. Alan, sorry. I want to mention that there's a whole bunch going on in the Rust community right now, a lot of events around the world. If you go to the Rust website, there's a new link that goes to the community calendar. There are regular events in both Paris and Seattle. There's also starting to be some spun up in Tokyo, and there's kind of talks at conferences periodically throughout the year. Lots going on, lots happening, especially as we ramp up to 1.0. It's very exciting. So keep an eye on that. Thank you, everybody, for coming. It's really been a pleasure. Thank you. Good night.